Hello, it's intervention video time, and I had a request, like an actual request. And the person that did the request wanted to have a bit of a tutorial on probability. So that's what we're going to look at. That's what we're going to look at right now. Now, probability in itself is quite a large topic area. If I did a full-on video on anything you could want to know about probability, it would probably getting along for an hour to 2 hours long, which is not what this is all about. So I'm going to do mostly everything you could want to know about probability. I'm going to go over like key concepts, key ideas, and I'm going to leave people to get back to me and say, can you focus a little bit more on this? Okay, so if you're the person that requested the video, and hopefully you're watching it, could you get back to me and tell me what specifically you'd want to see? Okay, but we're going to go with this for now. So we're going to look at trying to diagnose the question. We're going to look at methods for completing a question, and we're going to look at expectation. Because if we're thinking about crossover, so the first few questions of higher, last few questions of foundation, and we're looking at the higher tier paper in general, those are the things that I would expect to come up in some way, shape, or form. The difficulty of the question could vary quite a lot, but at least we'd be able to get started with the things that we're going to see here. Okay? And I've waffled on for long enough, so we're just going to get into it right now. So, first things first, the language of probability, okay? In questions, or if you play back the question to yourself, if you think about what the question is asking, and you're using some of these words, that can give you a big indication as to what you'll need to do in the question. Okay? So, for example, if we have a question and for example, we're asked to find the probability of getting something that is black and then something which is white. Okay, like thinking about maybe picking a black ball, then a white ball. The word "and" for this indicates to me that I should be looking to do some kind of a multiplication. So I might need to find the probability of something being black, the probability of something being white, and then multiplying the two things together. Okay? So, and in the case of probability, we can use to mean a multiply. Okay? So if I was thinking, I've got a deck of cards, and I wanted to know the probability of me picking out a king and an ace, in two successive draws, I would need to know what the probability of me getting a king is, what the probability of me getting an ace is. There are 4 of each in the deck, so that would be 4 out of 52 for both. And then multiply those two fractions together. Okay, so and multiply. Or, rather counterintuitive, you might think or would be to kind of multiply, but it doesn't. If I'm talking about something which is an or, for example, I might say the probability of getting a king or a queen in a deck of cards. If you think about it, I'm saying I could have a king or a queen. Which one? I don't mind. So my options have kind of become... I've got more options available to me. I could have any of the 4 kings, or I could have any of the 4 queens in that deck of cards. Okay? So what this actually means in terms of us working things out is that I could have the probability of me getting a king, the probability of me getting a queen, and I can add those two things together. Okay? Provided... So these two things depend upon us having something which is mutually exclusive. Okay? Now, you might remember that I've used this word or these words before, mutually exclusive. Okay? So mutually exclusive means that it cannot happen at the same time. Okay? So this cannot happen at the same time. For instance, if I was pulling out one card from a deck of cards, I couldn't pick out a king and a queen at the same time because, well, you can't. You either get a king or a queen. So that would be an example of something which is mutually exclusive. You can imagine picking biscuits out of a biscuit tin. If you dip your hand into a biscuit tin that has only got custard creams or bourbons in it, you're not going to get a custard bourbon. Okay, you're going to get a custard cream or a bourbon. You can't have both at the same time. Okay? If we have things which are mutually exclusive, so things that cannot happen at the same time, we get some interesting facts that can help us work out some problems. For instance, that the sum of all probability should add up to be 1. Okay? So if I take all of the events, all of the different outcomes, and I add them all up, I should get 1. Okay? So that's the first interesting thing. The second interesting thing is the probability of me not having something. Okay? This little notation here where I've got P with a little A, I'm not sure that the recorder is picking up my little mouse, actually, so I'm going to get the pointer. That little apostrophe there, that can just be used to mean not. Okay? So the probability of A not happening. Okay? If we have mutually exclusive events, the probability of A not happening is the same as 1 take away the probability of A happening. Okay? So, just as a quick example, if I wanted the probability of me not getting a king, probability of a king not happening, I would need to know what 1 take away the probability of getting a king would be. Now, if you know your deck of cards, you've got 4 kings out of 52 cards in a deck. So 1 take away 4 out of 52. Well, 52 take away 4. It's going to give me 48. So 48 out of 52. So the probability of me not getting a king, if I pick out just 1 card out of a deck of cards, is about 48 over 50. Well, it is 48 over 52. Okay? And if you can think to yourself what the question is asking you to do, and you're using the word and or the word or you're needing to find out what all of your probabilities add up to find a bit that's missing, these are certainly some things that can be extremely helpful. Okay? And before this video is over, I'm going to look at a couple of questions. Just look at the questions, not necessarily do the question. But I'm going to look at the question and say, right, this means we need to do this. This means we need to do this. Okay? So, the language of probability is very important. It can give us a really good indication of what we need to do. Okay, so after we've thought about some of the language of probability, there are some other things that we might need to kind of work out. One of the things that you could be asked about on either tier is something called expectation. Okay, and it's to do with how many of something you would expect to have, or how many of something would you predict to have, or something like this. And the easiest way to have a look at this is to look at a single question. So we have a question here, which says that an experiment is done where in a crowd of people, we count the number of people that have blonde hair. In a crowd of 200 people, there are 60 who have blonde hair. Okay, and we want to predict how many blonde people would we expect if we had a crowd of 2,000. Okay. Now, the numbers in this work out quite well. I'll look at it on the left-hand side because the numbers are quite nice. Okay, so if I have 200 people, okay, and 60 of them are blondes. Okay, well, if I had 2,000 people, I would expect roughly, well, if I've times by 10, I'm going to times by 10 again, I would expect roughly 600 blondes. Okay. This could be referenced as an estimation. So it might say estimate the number of blondes that would be in a crowd of 2,000. It could be under an approximate. Okay. We could be using any of those words to put this question into practice. Sorry. Now this worked out because the numbers were quite nice. So we were happy with our numbers here. If the numbers are not so nice, okay, we might say, okay, what is the probability of us picking a blonde in our first crowd? Well, there were 60 blondes, and there were 200 people. Okay, that would be a fraction. If I wanted to know how many people I would expect, well, I'd have to do my probability of me getting a blonde and then timesing that by my number of trials, or in this instance, how many people. Okay. So in this case, I'd have to do 60 out of 200 multiplied by 2,000, which still works out at us having 600 people. Okay. And these kinds of questions could be done with anything. I mean, you could be looking at cars that are going past, and you could say, out of 50 cars, 3 are silver. Tell me how many silver cars I would expect for 100 cars, or anything like that. Anything that you could go out and measure. Okay. This kind of a question is sometimes referred to as experimental probability, because you have to normally do some kind of experiment, some kind of measure, before you can actually work something out. Okay. For instance, you might flip a coin 20 times and see how many heads you get, and then be able to say how many heads you would expect if you'd flipped it 70 times, or something like that. And expectation could be higher or foundation. There is one downfall to expectation, which is that it is only an estimate. Okay, the actual number could differ. It could be more, it could be less. We're just getting an estimate because we're assuming that everything stays in proportion. Okay, and that could be a one marker that we might have to comment on. We are assuming everything is in proportion. Okay, so that the same proportion of blonde people for the small crowd and the same proportion of blonde people for the big crowd. Okay. Now, on a higher tier focus, or more of a higher tier focus, you can still see some of these things on the foundation tier, are questions that can involve probability trees or Venn diagrams. Okay. Now, some of these methods work out better for particular kinds of questions. Okay, so for example, things which are mutually exclusive. Okay, so things which one thing cannot happen at the same time as another. Tree diagrams are extremely useful. Okay, so if you think about the card questions that we were looking at earlier, those are the sort of things which could really definitely be done with a probability tree. Okay, Venn diagrams I would use for not mutually exclusive. Spelling mutually exclusive. There we go. Now, these are things where you could have something which could happen at the same time. Big ones for these are subjects, sports, or something where you could have someone that does more than one thing. For instance, you could have people that study biology, people that study sociology, and you could have people that study biology and sociology in the middle. Okay? So these people would be the people that only study biology. These people would be the people that only study sociology. These would be the people that study biology and sociology. There's that word "and." Okay? And this would be the probability of someone, or the number of people that do not study biology or sociology. Okay? And those words, the "or" and the "and," still apply to these two methods. Okay? So, let's have a think. Okay, so, what I've done is now taken a selection of some questions. And we're not going to do the questions per se, we're going to just look at what the information we've been given is, what do we need to draw upon from our language of probabilities, so these things, or the methods that we have to us to look at a problem. And see then if we can draw upon what we need. So, top one up here, I've got Lewis, who surveys 140 students in his year group to find out if they sent text messages or emails last week. Okay, so sounds fair enough. He's got 140 students. We're looking at text messages and emails. So 79 students sent text messages and emails, and 126 students sent text messages. Okay, now, looking at this, I've got a section here which is text messages and emails. Now, if I'm thinking to myself as well, I could send a text message and an email. There's nothing to stop me saying, there's nothing in the question to say I can only do one or the other. So in theory, we could have both. Okay? And the fact that we could have both, someone who does a text message and an email, okay, tells me that this is not, this is not mutually exclusive. Okay, so this is the exact kind of question, this one, that I'd be like, I need a Venn diagram. Okay, more often than not, if you need a Venn diagram, it's often drawn for you, but that might not be the case, just so that you're aware. Okay, so I would look to have a Venn diagram with two circles in it, one for my emails, one for my texts. I have 79 students who sent both, and overall 126 students who sent a text. Now 126 take away 79 is 47. So there should be only 47 students that just sent a text. Okay. So this would be the kind of thing that would get me started with this problem. It might be that I'm asked, what's the probability that someone did not send a text? In which case, I'm going to have to look at how many students I've got, how many people did not send a text, and then write that as a probability. For the second one, we'll go for green. We've got a bag that contains toy animals. Emma takes an animal from the bag at random. The probability of choosing a sheep is a fifth. Okay. So let's think. If she's taking animals from the bag, she can only take one animal at a time. So she couldn't have like a sheep cow. Okay. Just a sheep. Okay. So these are mutually exclusive. Is nice. I'll just write mutually exc for now. And I want to, first of all, think the probability of choosing an animal that is not a sheep. Okay, so probability not a sheep. And if we remember, that's 1 take away the probability of us having a sheep. That's fair enough. Part B, the probability of choosing a pig is a half. What's the probability of choosing a sheep or a pig? Okay. Well, this is the point where you think back to yourself and you think, okay, I have those keywords. What did they mean? And was where we multiplied. But I don't want a sheep and a pig. I want a sheep or a pig. So I would have the probability of me getting a sheep, the probability of me getting a pig, and I would add those two things together. That is what our keyword for or means. Okay? Now, the probability, the table shows some probabilities. From the new spec, over the last, 4 years, 5 years, whatever it's been since we've been doing it, probability questions in tables have come up, I think 2 or 3 times, something like that. And you might be asked to fill in some gaps. Okay? And in which case, it's really, really useful for us to know what probability should add up to make. I'm going to change color again. We'll go for dark blue. Dark blue is good. Okay. And probability should add up to make. And if you said to yourself 1, you're absolutely correct. And we have to look at the question for some detail. The spinner is equally likely to land on 3 as it is to land on 5. So I could say, all right, if that probability is probability X, that will be probability X as well. Okay. Little side note. If it said that probability of us getting a 3 is twice as likely, then I would have to think, okay, if the probability of me getting a 5 is X, if probability 3 is twice as likely, then it would have to be 2X. Okay, and then, again, we add everything up, should make 1, then we can find out what our value of X should be. Okay, and then for our final little bit down here, we've got the probability, a spinner is spun 300 times. How many times would we expect the spinner to land on a 4? Well, our expectation, because it did use that word. Okay, we have used that word expect. Our expectation, get back here, is going to be the probability that we would normally land on a 4 and then times by how many trials or how many things we are looking to do. Okay? So that kind of gives you a rough overview of some aspects of probability, like a general overview, okay? The things that you'll probably need to use most are one of these two things. Okay? And we looked at some things recently to do with probability trees. If you're going across two branches, for instance, if you're following this branch up here, you have to multiply probability A and probability B together. Okay? If you want more than one branch, say you were looking at the probability of this top branch or the probability of this very bottom branch, you would have to take those things and then add them together. Okay? As I say, we had a look at a probability tree or two recently, so I'm not going to go into a huge amount of depth on that. I do take requests, okay? If you want to look at a specific topic or a specific section of the course again, because it's been a while, then by all means, go on to Teams. I'll bring it up. There we go. Here's Teams. Yeah, so if you go on to Teams, and for you guys, you got your 11B MA2. If you go into Files, and not your on-demand intervention, where am I going? Class Materials, here we go. You've got this here, which is the higher tier contents page for the textbook, okay? And if you click onto this, you can see all of the different sections that we have looked at. We are currently about here, okay? So after this chapter, which should take us maybe another week and a bit, we've then got 2 more chapters left, okay? 2 more chapters, that will be it, okay? We've got plenty of time for revision, and that means that it is especially important that you tell me what you need to revise. I've got in my own head things that need to that we should revise, but if there's a particular thing that you want to see a video on, or if there's a particular thing that you just want a little bit more depth about, then it is absolutely important that you let me know. Even if it's like, sir, just remind me about circles again. Like, remind me about areas of circles again. Or if it's, going right back to those first few lessons of year 9 and thinking about highest common factor and lowest common multiple. Anything, just let me know and use this as a kind of thing to fall back on if you're not sure about the sections that you want to look at, okay? But that has been mostly everything you could want to know about probability, okay? Disclaimers added, okay? If you want me to go into a little bit more depth about Venn diagrams or tree diagrams or not mutually exclusive problems, again, shoot me an email, let me know in class, and then I will absolutely do that as our next video. See you tomorrow. Well, my tomorrow. Your today. Sounds a bit weird.